In this video, we'll cover the standard free energy changes for a couple reaction. So before I even begin to introduce a couple reaction, try to find the delta G naught of this particular equation where you have the zinc sulfide forming into zinc solid and sulfur solid. So go ahead and find it again, the delta G naught by utilizing the delta G naught formation equation. So here is the key for that particular delta G naught. You will get 201.3 kilojoules, which lets you know that this is a non-spontaneous process since it is a positive value. But how do we get this reaction to become spontaneous? And you can by going through a coupled reaction. Coupled reaction is just taking one of the product over here and allowing it to react with something else that is very spontaneous. For example, here is this sulfur right here, and that sulfur can be added with oxygen. So you add oxygen during this reaction, the first reaction occurring, so that this sulfur will form into sulfur dioxide. This is a highly favorable reaction, so hence why it's negative 300.1 kilojoules. So knowing that this negative 300.1 kilojoule is a very much a spontaneous process, it will sort of overpower that non-spontaneous by a factor of, I don't want to say factor, by about 100 kilojoules, right? Since this is much higher, we can put these couple reaction stack on top of one another to find out the overall spontaneity of this particular reaction. For example, you would take sulfur or zinc sulfurs. I'm just rewriting the very first equation on top, but right next to it, I will let delta G naught is equal to 201.3 kilojoules. Right underneath it, you're going to write the second equation that helped this first reaction to go forward, and this had a delta G naught of negative 300.1 kilojoules. And you're going to go ahead and just add the two and find its net, meaning that here's my sulfur here on the product side, and here's my reactant here on the reactant side. The sulfur is on the reactant side and one sulfur is on the product side. You could cancel these out since it's on the opposite side. Everything is left over, so therefore you write zinc sulfur solid plus the oxygen forming into zinc solid plus sulfur dioxide gas. All right, so that's it for the equation portion. But on the portion where it says delta G, you're going to go ahead and add the top and the bottom together. So 201.3 minus the 300.1, and you would get negative 3.1. So you get negative 98.8 kilojoules. So what does that mean? That this reaction now is spontaneous. We can take that non-spontaneous reaction becoming a spontaneous reaction by coupling with another reaction that is highly spontaneous. In this learning check, we will do a very similar problem as previously. Is a reaction coupling the decomposition of zinc sulfide to the formation of H2S expected to be spontaneous under standard conditions? See reference sheet for delta G naught values. The very first reaction, we already know that this is a non-spontaneous reaction. And we calculated that non-spontaneous reaction in the previous slide to be negative 200, positive 201.3 kilojoules. We're going to have to find the delta G naught for the second reaction. So go ahead and find all of the G values for all of these guys and find the delta G naught and come back. So hopefully you were able to get negative 33.4 kilojoules, so that this reaction is a spontaneous process, negative 33.4 kilojoules. Now, as we have done before, we're going to add the top and the bottom together on the where it shows the equation and also delta G. So let me go ahead and erase this just to give you more room and some clarity. And so therefore, we're going to go ahead and look at the top value over here and the bottom, and also the top equation in the bottom. You can definitely cancel out the sulfur, okay, since on the reactant and the product side is exactly the same. If I were to add the top and the bottom, we have zinc sulfur plus the hydrogen gas forming into zinc solid, and then plus H2S gas. Now, if I were to add these two guys together, then I would get 167.9 kilojoules. And so this is a positive value. So even though this reaction is coupled with a non-spontaneous reaction or spontaneous reaction, it's not strong enough. The spontaneity is not strong enough in order for this to go spontaneous. Having this positive delta G overall, even with the coupled reaction, would be considered to be non-spontaneous.